We're going to get started on the final project, and during this project we're going to develop a marble game. We're going to explore the basic concepts of using the physics engine inside Unity to control a sphere through a level that contains hazards and some other elements that we want to apply some game mechanics to. So to get this process started, before we commit to the actual project, what I'd like to do is create a Sandbox project. So I've already created inside Unity a new project, and I've saved this to my desktop and I've called it Sandbox. And this is the place where I'll play with and experiment with some of the physics and explore some of the implications of using physics inside Unity. I'll also start to use this as the environment to implement and refine some scripts. And then once I get the handle on the basic concepts, I'll transfer this over to my final project folder. So to get this process started, I've created a Sandbox project. I'm looking inside Unity, and I just have a scene that only has a camera inside the environment. And unlike our previous project where we used a character controller that came with a camera, this time around we're going to use the main camera that comes with our default project. Now, to get this process started, I'm going to start off by creating a terrain, and I'm going to select that terrain, and this time around I'm just going to reduce the resolution of this quite a bit. So I'll reduce it maybe down to let's say 200 meters square. I'll set that resolution, and this will give me a smaller environment to work inside. And to get this process rolling, I'll also introduce a directional light because I'll want to see what I'm doing here. I'll take the intensity down just a little bit. And I'm going to start off with just a real simple reference object. So I'm going to create a cube, and the cube I'm going to make 2 meters tall. Now remember, when we're inside Unity, the size and scale of things are not arbitrary. So for 1 unit inside Unity, we're always referring to meters. And that becomes important, particularly when we're dealing with the physics engine, when we start dealing with the rate things get affected by forces and how quickly things are falling inside space, how gravity is affecting objects. So just to get this reference set up, what I'm going to do is I'll zoom in a little bit. I'll go to the move tool. I just want to move this down towards the ground. In fact, maybe what I'll do is I'll just zero out the position. I'll double click on the cube to frame that into view. I'll just move it up a little bit, and if I move that Y up to 1, I know that's sitting right on the terrain object. Now if I look down, the registration point for the terrain object is in the corner, and I made it 200 meters wide by 200 meters deep. And so what that'll allow me to do is I can set the X value to -100, and I can set the Z value to -100. And when I do that, that should place the object that's at 0, or the origin of my 3D space, pretty much in the center of the terrain. So that's kind of what I'm going for. I have this cube in here just for reference. And the other thing that I want for reference is I want to add a little bit of variation to my terrain. So I'll select my terrain, I'll jump in with the brush tools, and I'm just going to, I'll grab a big brush here, and I just want to kind of paint in here just to get a little variation. So as I start moving around and kind of playing with the environment here, I have some hills and some other things inside my environment that'll give me a better sense of space. Now, let me just select my cube here and make sure that I'm not way off in space. Just make sure that's kind of sitting up. And again, this cube is just for reference. Now, I'm going to name this cube, I'll call it, this will be our person ref. Or maybe I'll call it ref person, so it's a reference for our person. Now, the first thing I'm going to do inside my environment is I'm going to create a game object, and I'm going to create a sphere. And I just want to explore the concept of physics inside Unity. Now, I'm going to double click to find my sphere, see where it's placed, and here's my sphere. Now this sphere, I'll just move it off to the side and up. This sphere is 1 meter in diameter. So this 1 meter sphere, it has a size inside our relative environment. And now this becomes important because if I take this sphere and I just kind of move it, I'm going to move it way up. I'll move it way up in space, okay? And I have this sphere, and if I want to start to influence this by using the physics engine inside Unity, it's very easy to do this. Now, actually, before I do that, I want to select my camera, and I want to make sure that my camera is actually looking at this, because when we hit the play button, we'll actually look through this camera. So when I select my camera, I can see my camera preview is not looking at anything, so I'll just kind of recompose the camera. I'll move it around, and I'll move it back, and I could move this up just a little bit, and I can rotate my camera a bit, but I think I'll be able to see what's going on inside the environment. So again, when I hit the play button, I'm looking through the camera, and I see the environment. Maybe I'll move that off just to the side a little bit as well. I'll back it up just a bit, and I'll lift it up. So I'm going to go back and select my sphere. Now, the basic idea of the physics engine inside Unity allows us to select an object and tell the physics engine to use that object or apply physics and let it be affected by gravity. And it's very easy to do this. I can just select an object, go to the component menu, and choose physics. And from physics, I can choose the rigid body object or the rigid body component. And once I do that, you can see that my sphere has included a rigid body component is now attached to my object. Just by choosing the object, going to components, and choosing rigid body, that applies a rigid body to that object. And now when I hit play, you'll see here in a moment that my sphere falls into the environment. And it continues to roll based on what the terrain is doing. If the terrain is running downhill, that ball will kind of roll around. This is now a rigid body. It's something that we can run into and we can push around. So to get the physics engine inside Unity to acknowledge an object, it's just that simple. We select an object, and we choose the component, physics, rigid body. Now, when I hit the play button, and I'm going to back my camera out just a little bit so we get a better view of this. I'll back my camera out, I'll move it up so I have a wider frame here, and I'll hit the play button. And you can see that eventually we have this ball falling through space. Now that may seem like it's falling fast or slow. I'm going to introduce another sphere. And I want to stress the importance of the size of things relative to the physics engine. I'm going to create a sphere that's much larger. I'll move that up to the same point in space. Now, there's sort of this illusion when we're working with objects inside Unity. I need to select my big sphere. I'll rename it. I'll call this big sphere. With that sphere selected, I need to go to Components, Physics, and add the rigid body. Now when I hit the play button, both of these objects are falling through space. Now, there's this implication that the larger sphere might be moving slower than the smaller sphere. Now, they're actually moving at the exact same rate. And the idea here is that if we consider this sphere to be a relatively small size, and I'll just select my camera and I'll even move out a little bit further so we see that big sphere. If we're considering this sphere to be the size of a tennis ball, and it's inside a relative environment, that sphere could feel like it's moving really slow. Okay, and what I mean by that is that if we're building a tennis game, or we're building this marble game, and we do it on this really large scale, so that our marble is 10 meters, or almost 30 feet wide, we're going to have a different scale. It's going to be influenced by the physics in a different way. And so what the idea here is that if I make something that's gonna give me a reference to something that's the size of a building. So let me just make a cube, and I'll set the X value to 10 for scale. I'll set the Y value to say 100 meters, and the Z value to 10 as well. So I have this relative object. It's pretty tall. We'll consider this the size of a skyscraper or a building. Now when I hit the play button and I look at these objects relative to that building, things appear like they're moving a little bit faster, okay? Because we're covering a greater distance than we are if we don't have that object reference, okay? So if we're falling a few feet per second, that speed reference is going to be relative to the size of the environment that we're in. So the basic idea here is that if we get rid of this cube object for a moment, I'll just turn the mesh render off, and I hit the play button, that sphere appears like it's falling very slowly. So the little sphere does as well, but the big sphere, it feels a little bit more obvious. It feels like it's falling slowly unless we consider that it's falling relative to an object that is extremely large. So if I just turn this mesh render back on, let's try that again, turn that mesh render back on, and think of that object as the relative size of a building. And then we look at that small sphere that's falling through space, and we see that sphere accelerating. All of a sudden, the space or the distance at which it's falling is put into perspective, okay? And I can't stress that enough when it comes to physics, that we really have to keep that in mind, because we don't want to create things too big. So the first thing we need to do is create our sandbox project, create an environment that has a cube reference that's roughly the size of a person, and start to apply some basic physics into the environment with the sphere, and let it roll around and just see how that gets affected by the Unity environment. We'll catch up in the next presentation, and we'll continue to apply some physics to some other objects, and we'll start to control those physics with some basic scripts that I'll provide, and we'll do that in the next presentation.